I would like to continue discussing biodiversity and how humans can impact biodiversity. The case study we're going to look at is dams on the Susquehanna River. There are 10 dams on the river. 4 are hydroelectric dams that were built between 1904 and 1931. The first 4 dams actually slow or even stop migratory fish from passing them by going upstream or downstream. These dams do have fish ladders and fish elevator systems put into place to assist with the fish migration, but they have been largely ineffective. They also do not work for the American eel. So fish are having a tough time migrating up and down the river, and the American eel is also having a difficult time because these dams are in place. In 2014, the data indicates that only 8 shad made it past the 4th dam, compared to the millions of shad that once would swim up and down the river. The goal that the government has set is 2 million fish being able to swim up and down the river by changing this framework that is currently set up with these 4 dams and doing something to improve fish migration. So this graph shows the American shad passage reports on these 4 dams from 1997 to 2006. The red indicates the Conowingo Dam, the blue indicates the Safe Harbor Dam, the green is the Holtwood Dam, and the yellow is the York Haven Dam. So this is the American shad numbers that get past the dams. So out of the 4 dams, it appears that the York Haven Dam has the least number of shad that are getting past the dam itself with whatever fish ladder might be in place. Then next is the blue, which is the Safe Harbor Dam, as having the least number of shad get past it. And then the green is the Holtwood Dam. And finally the red is the Conowingo Dam. So the Conowingo Dam is the one that's been the most successful in having the most number of shad get past it, followed by the Holtwood Dam. The dams also trap sediment and let pollutants build up behind the dam. The reservoirs behind each dam has been filling with tons of sand and mud. 3 of them have actually reached their sediment holding capacity, and the 4th, the Conowingo Dam, is quickly approaching sediment capacity. If the dam were to fail, a massive flood would occur, and it could send tens of thousands of tons of sediment and pollutants into the Chesapeake Bay all at once and cause massive damage to the Chesapeake Bay ecosystem. So we are trying to figure out how to resolve the amount of sediment that's behind each of those dams along the river so that we don't have potential instability of the dam and potential for a breach of the dam with heavy sediment loading impacting the Chesapeake Bay. So overall, looking at this graph, we've seen an increase in shad passages on the dams up through 2001, but now we're seeing a general decline in the number of shad that are passing the dams via the fish elevators or the fish ladders. So more on the Susquehanna River. The Susquehanna River has over 49,000 miles of waterways within the actual watershed basin, and this is a depiction of the watershed basin on the far left and a better depiction of it here on the right, where the light blue is considered to be the main stem of the Susquehanna River, completely in Pennsylvania with a little bit here south of us, Maryland, and then this is the Juniata Basin, or the Juniata branch of the Susquehanna River. This is considered the west branch of the Susquehanna River. And then the yellow is the Chemung Basin, which stretches up into New York. And then we also have the pink, which is the north branch of the Susquehanna River, which also extends into the New York State. These are the Finger Lakes in New York, and they are not included in the Susquehanna River watershed. But it's a large watershed that encompasses Maryland, Pennsylvania, and part of New York. There's about 6.1 million people that live within the watershed, and that's a good number of people, and they get their water from the drinking water from the Susquehanna River Basin. Here at the bay, where the river empties into the Chesapeake Bay, about 18 million gallons of water flow into Havre de Grace, Maryland, every minute, and that's a lot of water. The Susquehanna River also is the largest tributary feeding into the Chesapeake Bay, and it provides about 50% of the flow of fresh water into the bay. The widest point in the river is actually found at Harrisburg, Pennsylvania, and the river is nearly 1 mile wide. So some more fun facts about the Susquehanna River. About 27,000 square miles of land area is being drained by the river, and whatever land use is going on in this land area basically is what impacts the water quality within the tributaries and streams and the river itself, and that land use also contributes to what's going on to the bay. So the data indicates that in 2003 the river contributed about 44% of the nitrogen loading that was going into the bay, 21% of the phosphorus loading, and 21% of the sediment that was going into the bay. So we are largely responsible for the water quality in the Chesapeake Bay estuary area. By the way, in 1997, the river was designated as an American Heritage River by the Environmental Protection Agency, and this designation allows for technical assistance from federal agencies to work within the Susquehanna River watershed to assure that its water quality is good. Now, over the years, the water quality has decreased because of overloading of nutrients and water quality concerns. In 2016, the American Rivers Organization named the Susquehanna River the third most endangered river in the country, and that's partially because the water quality decline has occurred. Okay, so let's get back to this topic of the dams on the river. One of the biggest problems in the Susquehanna River watershed is the loss of the American eel population. This in turn is decreasing the freshwater mussel population as well. Here's a picture of the American eel, and here's a picture of the freshwater mussel. So what's happening is the eels are not making up these fish ladders to get from downstream to upstream for their normal migration route, nor are they making it up these what they call fish ladders or eel ladders. You see a few that are making their way up this structure, but still we're having a lack of migration going up and down the river. What happens is that mussels put off their larvae, and the larvae actually attach themselves to the eels, and as the eels swim up and down the river, it helps distribute the larvae of the mussels and helps propagate them. So because the eels aren't getting up and down the river for migration with the dams being in the way, we're seeing a ripple effect of impacting the eel population and the freshwater mussel population as well. There have been recent attempts to stock the American eel in the river, but since the ladders and elevators don't seem to assist the eels in any measurable way, it's really not having any positive impact. So we're seeing some problems with having these dams on the Susquehanna River and the migration of fish, in particular the shad, and in the migration of eels going up and down the river. And that's because these dams contribute to habitat fragmentation, basically. So there's pros and cons to putting dams on river. Pros are that it can generate electricity and power for the people that live in Pennsylvania and Maryland. A pro is that it creates jobs when you're building the dams as well as maintaining the dams. Another pro is that the dam can provide large areas for boating and other water recreational activities in the reservoir behind the dam, and the dams can help with flood control. The cons are that there's been an increased impact on the Susquehanna River in water quality and sediment as a result of the dams, and there's risk to the Chesapeake Bay with having these dams on the river. Habitat fragmentation was already mentioned in relation to the migration of fish and eels, and that's resulting in a decline in freshwater mussels also. Further loss of biodiversity from the dams are being investigated and trying to be determined if there's any further impact on the economy other than what's going on with the shad and the eel. The Susquehanna River also provides millions with drinking water, and hence, water pollution within that watershed is a concern. So let's look at invasive species.